Hey guys, Dr. Brown here, and tonight we're talking about the chain rule. So those of you in Calculus 1, if you're like me, I thought the teacher had lost his mind when he came to this, because up until this point, we had taken derivatives of functions like this. So if we said, okay, what's the derivative of 3x squared plus 2x? So I'm looking for f prime of x. We would bring the 2 down, so I'd have 2 times 3, x to the 2 minus 1, plus, bring the 1 times 2, so that's 2x to the 1 minus 1. That's what we would have. So that would end up being f prime of x equals 2 times 3 is 6, x to the 2 minus 1 is x to the first power, x to the 1 minus 1 is x to the 0. Any number raised to the 0 power is 1. 1 times 2 is 2. So the derivative of 3x squared plus 2x is 6x plus 2. Yikes. What if we did this? Okay, I'm going to take this guy and cube it. Now I want to take the derivative of that. How do I handle that? Oh, what to do now? All right. If you're trying to look at this in terms of the chain rule, I try to think about it as an outside function and an inside function. So if I'm trying to take the derivative of this thing, I need to take the derivative with respect to x of the outside function times the derivative with respect to the inside function. Now you'll notice I've boxed this out. I've got an outside, this function is cubed. So the outside function is, I'm taking everything in here and cubing it, but I need to take the derivative with respect to that. So let's let u equal 3x squared plus 2x. So du, and we just did that earlier, that's 6x plus 2. So now let's say we have a function that's u cubed. So f of x equals u cubed. We would think, well, that's easy to take the derivative of that. Bring the 3 down, 3 times u to the 2 minus, or 3 minus 1, which is 2, times the derivative of the inside, which the derivative of the inside is du. So this becomes 3 times u, 3x squared plus 2x squared times du, which we said was 6x plus 2. So what does that give me? I'll distribute the 3 in here. I have 18x plus 6 times 3x squared plus 2x squared. And that is the chain rule. Let's take another function. What if I have sine cubed 4x? So f of x equals that, which I can rewrite that. Sine 4x cubed. So now I have an outside function and I have an inside function. I actually have more than one inside function. So let's let u equal sine 4x du. So now I have that situation, right? So I can go a little deeper into that. So the derivative of sine t, let's say, we would say would be cosine t. In this case, cosine 4x times the derivative of that inside function, which is 4 dx. In case this part in your differentiation, you're probably not digging into the x. So that's what du would be. So now let's go back to this function. So f prime of x would be, I have, that was u, I have u cubed again. So that's f of x. F prime of x, 3 u to the 3 minus 1, which is u squared du. And du then is this term right here. So I have 3 sine 4x squared, and du is 4 cosine 4x. Actually, I'll leave the dx up there. So 3 times 4 is 12. I have 12 sine 4x squared cosine 4x dx. And that's how you use the chain rule, and we use the general power rule as well within that, to end up getting a derivative where there's an outside function and an inside function. Now, in many of your textbooks, they're going to say the inside function is g of x, and this would be f of g of x. And just to be honest with you, that was a little confusing to me. So I just said, here's an outside function and an inside function, and that's when I could really get going with it. You find what works for you, okay? Hey, together, let's build a better tomorrow through math. Keep studying, and we'll talk to you next time. Thanks.